All right, this is exercise 4 for week 11. We have taken the point array program and we've modified it slightly. We have added a method called copy array, and it takes a point array as an argument and it returns a point array as a return type. The idea here is that it's going to take in the source and spit out the copy. I want to concentrate on this method first before we look at the execution of the program and how that plays into the values that we're seeing. What I want to look at is the process by which we make a copy. When we think about arrays, you have to remember from our discussion, we can't just simply use double equals or even the assignment operator. Because what ends up happening is we're just passing around essentially an arrow to the original array. And when we make a copy, that's not what we want. We want a duplicate but discrete and separate item so that any changes made to the copy do not affect the original. Okay? The same idea of me making copies of a handout and you making all the changes that you want to that handout to fit your learning style or any notes that you feel like you want to make on any of the programs. Your changes don't affect your neighbor's changes, don't affect my original. Although in some ways I think that might be cool. But that's beside the point. That wouldn't be a copy. In this case, we're looking for a copy. So, when we think about copying arrays, we need to keep two things in mind. To be an identical copy, not only does it have to be the same size, but it has to contain the same values in the same locations. Almost the same idea that we're using when we want to determine if two arrays are the same. So let's look at point copy. What does it do? Well, we create a new point array called temp, and we make it the same length as our source array, which in this example is A. And then we go through and we create, for every item in the list, we create a new point item with the exact same value. And I got some excess code here. Let me just get rid of that. For every item in point array, we create a new item with the same value. Okay, that's one thing we have to keep in mind with objects is that we have to create an object with the exact same value when we're doing arrays of objects. When we're doing arrays of primitives, it's easy. It's just whatever's in position 1, you put in position 1 of the new array. Whatever's in position 2, you put the same value in position 2. When you're dealing with objects, it's the same idea, but it gets a little more complicated because you've got to figure out what constructor to use. In this case, I'm calling the point constructor that takes one integer. And then when it's all said and done, I'm sending back a reference to temp, this new array that we've created. And not only have we added this code, but we've added some code to our main method. What we've added is the creation of a new list, a new array of point items called list2, and we're going to essentially fill it with the copy array, with the results of the copy array method, which, as you know, takes in a source and spits out a duplicate copy in a separate memory location. I'm going to print out a blank line, and I'm going to print out the contents of list 2 using our display array method that we talked about previously. Now, when we look at a list and list 2, they're going to look the same. So I went ahead and at list 2 in the first element in the first item in list 2, I've called that item setX method, and I've changed x to 5 so that it is 0 and 5 instead, or 5 and 0. Yeah, 5 and 0 rather than 0 and 0. And I'm going to print out a blank line. I'm going to print out the contents of list 1 and then print out the contents of list 2 so we can see the difference. Let's take a look at the data. So here are the results of the program. So this is the load. This right here shows the load and run of list 1. And that was the original code that we had. Then we created a copy called list 2. And this is the result of the value stored in list 2. Now, right after this happens, I change the x coordinate of the first element of list 2 to 5. So the next time we see the contents of list 2, it should say 5 and 0, and then 1 and 1, 2 and 2, 3 and 3, 4 and 4. If we look back at list, again we notice 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. But now when we look at list 2, after we've made the change, after we've changed the x value of the first item, we see 5, 0, 1, 1, 2, 2, 3, 3, 4, 4. So we have indeed made a completely discrete copy. And by discrete, I mean separate and unique. Copy of that list, so that when we make changes to list 1, we're not changing list 2. Now, exercise 5 has a method called bad copy, which performs a bad copy. It uses double equals to just essentially assign value. And that's not a great idea. If you do that, and you change copy array to bad copy, you will discover that these results don't quite work that way. Now, I'm going to avoid, while I'm telling you this, that this is how it works. I'm telling you this because if you choose to go through that exercise yourself, you can see what happens when you do an incorrect copy. I'm not even going to go over that. I've shown you the right way to do the copy, and we're going to leave it at that. If you have any questions about exercise 5, feel free to email me, bsimbeck@ccac.edu. And there is not going to be a video for exercise 6. Exercise 6 is a completely on your own setup. The idea here is to see if you can work through that program and understand how it works. In that case, we're using an array as an instance variable to a class. And I think it's important to understand, but I also think you guys can figure that one out for yourselves. There isn't a whole lot special to it. I mean, if you just think about an array as any other sort of item that you might put in a class, in reality, it becomes pretty easy to deal with. Of course, if you have any questions about any of the exercises that we've talked about today, you can email me at bsimbeck@ccac.edu or bring them up to me in class. Thank you very much, and I hope you enjoyed the lecture.